to log in is taking me 10 minutes. And tomorrow, you as the software developer, you are playing with me to be patient. It's not actually a professional thing to do. So as developers, one of the reasons scaling must be at the back of our mind from the beginning of development is also performance. You know, also to leverage what containerization. Containers enable flexible deployment and scaling, providing consistent and efficient environment for your Java application in the cloud. Just like I said, as a developer, you might build your app in a corner of your office or your room. But your goal is not just your room. Your goal is out there, the global people. That user you have not met in person, that user you don't know. So you must look for a way to expose that application to the outside world. And that's where containerization comes in, where it makes your application flexible and also, put it in a container and push it out there so that anyone that needs the service of your application can have access to it. Now, understanding the why is crucial. We will delve into how multi-threading coupled with containerization address the crucial need for performance and scalability in today's demanding digital landscape. So when you are talking about, your application being an application users, long to use, users are happy to use, performance, and also the aspect of multi-threading are things you must put into it while you are building it. Remember, I keep saying while you are building, not when you have built it. Because when you finish building application, before you talk of that, there are many, many issues that might arise. And that's why I believe many of us joining this, for some of us, we are just starting a career as Java developers. And for others, we have advanced and we are making progress. So it's important you understand that these concepts are things you should have at the back of your mind, even while building from the scratch. So let's go to our first chapter. I just hope my time, I'll try as much as possible to keep the time. So the first aspect is talking about multi-threading in Java. I'm sure many of us, this is not our first time of hearing about multi-threading. So this chapter will be looking into that. Now, what is multi-threading? Multi-thread run concurrently within a single Java process, sharing the same memory space. Like I said, I'll try as much as possible to explain to the lead so that whoever it is that is not even a developer will try to understand. Now, when you enter a kitchen, for some of us that have gone to restaurants, you discover that all you do is to make an order, and whoever it is from the kitchen will just prepare what you order for and deliver to you. Supposing in this kitchen now of this restaurant, we just have one chef, and that chef is responsible for, pounding the pepper, bringing this ingredient, bringing this, and delivering. And you have one customer. Later, it increased to two customers, to 10, to 15. You discover that just this chef will need enough of, let me say, will actually have to seriously do enough to meet up with the demands of these customers. And these customers are hungry and they need to eat. So one way the restaurant owner can optimize the service in his restaurant is to do what? To employ more chefs. 10 chefs in the kitchen. Oh, how many people are ordering for fried rice? 5. Okay, 3 of these chefs handle that. And they will be handling. One person will be parboiling this one, and they mix it. And what happens? They dish out all those food. So when you are talking about multiple threads running concurrently in an app, it's just like those chefs all performing different functions to make sure that this food they want to deliver is what is achieved at the right time and they meet the what the customers need. Now, another aspect of multi-threading is utilizing multiple core CPUs for faster, more responsive applications by distributing workload. When you have a system today, you discover one of the things that is very, let me say, beautiful about tech is that it's dynamic. Many things are coming up, new things, are being introduced and all that. So we have multiple core computers and processors now. And one way to utilize them is to have multiple threads properly distributed for these CPUs to optimally be used. Yeah, it's like you have a powerhouse, but because you don't understand the weight of, deliverable it can do, you underutilize it. So multi-threading helps you, maximize the usage of your CPUs. Another aspect is commonly applied in web servers to handle concurrent requests. Yeah, we have a server, many requests are coming in, many requests are coming in. Multi-threading helps coordinate and control all those requests to make it more efficient, and also the data. Processing for efficient and UI responsiveness to prevent freezing, some of the challenges that come with multi-threading. So why multi-threading is important is for most of all these reasons. But in a nutshell, multi-threading is a powerful concept that allows your application to perform several operations at once, enhancing its efficiency and user experience. Like I said, this is not actually a teaching class. If I would have gone into this multi-threading, you discover that it's more than all these points we are raising, talking about multi-threading. So strong concepts and very deep that when you understand it as you build your application, you discover that requests that take, let's say, 10 seconds, within 3 seconds, it has been delivered. So multi-threading is a very, very strong concept that as a developer, it's important you study yourself with that knowledge so that as you build, you will, make your app more efficient. Now, that multi-threading is very good, when we talk about a software development, is what we call trade-offs. Yeah, as you are introducing some things or choosing a path to go as a developer, you must also understand the trade-offs. In other words, that it has advantage does not mean that it doesn't have disadvantage. But as a developer, you must have the skill to weigh the advantage, the pros and cons, and now go with the what advantage, depending on the scenario and the context in which you want to use such concept. Because as good as multi-threading is, permit me to tell you that it can be the reason why your app will be rejected by users. It could be the reason why your app will crash. So understanding the challenges or the disadvantage of using a technology can help you properly use such technology where need arise. Not that multi-thread is a good concept and anyway you just introduce it. No. So understanding the challenges it comes with will help us. And what are the challenges? Thread safety issues. Ensuring data integrity when multi-threads access the modified shared resources can be complex. You have one database, 2 people are trying to access the same record, and the integrity of such data can be affected. Multi-threading can introduce such. Race condition. You are in a kitchen. Let me use that kitchen illustration again, where 2 chefs, one is holding pepper, or pepper, permit me to use my intonation because thank God this computer class, not English, so you will pardon me in case I don't call it well. A chef is waiting for pepper and he's holding salt. The other person is waiting for salt and he's holding pepper. You are holding what I'm waiting for, and I'm holding what you are waiting for, and no one is releasing it. That's what actually race condition is. And they will indefinitely be waiting for each other. Sometimes it happens in code. You just discover that your code just freeze. Nothing is happening. In other words, it's race condition and deadlock that is happening. These are issues that could arise as a bid to use multi-threading, increase debugging complexity. You are multi-threading an app now, 5 threads or 10 threads, and an error occur. How do I trace where the error is coming from can be an issue. Because one thing you must understand about multi-threading is that most of them, like those running concurrently, are actually running to achieve one task. In other words, they are processing 1,000 records, but they are to bring one output. They are to sum this 1,000, data and to return one value. So multi-threading breaks it. Okay, you add 1 to 100. You add 101 to 200. And after we have processed everything, we'll now return, computable feature, return the final value. So you discover that when any of these threads have issues, if not properly, handled, it could be a point of what? Challenge when using multi-threading. So it's important we have these issues at heart so that as we're building, we'll also know how to properly handle it and, tackle it when it arises. Now, why powerful multi-threading introduces complexities? Awareness of these challenges in the first step towards building robust and reliable, concurrent application is very important. It's very, very important. Now, we have talked about multi-threading. Like I said, though, please always remember this is just a talk to give us a glimpse of what all this is all about. So you won't expect me to go nitty-gritty. Some of these concepts actually have code that we can even run and test. But since this is not a coding class, yeah, it's just to introduce us to these concepts and move on. So we are moving into containerization now. Remember, we talked about multi-threading, and that multi-threading comes from the grass unit of us building application. Now, after we have built it, remember when I started, I talked about the fact that the outside world need to have access to this application we are building. And how do they have that access? One of the ways is what? Containerization. Now, what is containerization? Containerization, like Docker, most of us, know Docker, are what? Provide lightweight and portable runtime environments. They encapsulate an application and its entire runtime environment for including the Java application, the Java virtual machine, the libraries, and other dependencies, for into a single isolated package. This package ensures consistent behavior across different environments, from a developer's laptop to production servers, eliminating the "it works on my machine" problem. Now, for some of us, I don't know how many of us, for those that, for some of our seniors here, you discover that when you started building application, there are times whereby you build and another person clones your app and now say, it's not running on my app, or it's not running on my app, and you'll be wondering, but it's running on my app now. For some junior developers that join an organization and the first task they gave them was to build an API that carries out something, you discover that you finish everything, you test it locally, but when it comes to production, they say, this your app is rubbish, it's not responding. And you'll be wondering, what is it, what is it, what is it? So this is one of the problems containerization come to solve. And in a nutshell, when we talk of containerizing your application, what it means is that the way you run it in your local, you just put it in one container like that. Everything. Is my DB working? Yes, put it inside. The dependencies, put it. What of the space? You put it. You put everything that your application needs to run into a container, and you now do what? You ship it out. Anytime anybody is talking about Dockerization, containerization, the ship always come in. Just like the diagram, you can see my diagram, a very big ship carrying your Java application with everything it needs. So in a nutshell, anybody or anywhere this application will run, it will behave the way it behaved in your local. So that's containerization for you. The way your application behaves locally, it's working on my local, it's not working there, it has been eradicated. Why? Because whatever it is you use locally, you have embedded and put it into your application before shipping it. So wherever you are shipping it, even if it's not Nigeria, the same output or behavior it gives you in Nigeria is what it will give you there. And that's where containers come in. And it eradicates all those issues of, the version of this you are using, this and that and all that and all that. Remember, I told you that with every pros or advantage comes what? Disadvantage. But it's important as a developer, you come to a point of weighing those pros and cons and going with, what is expected. Just like in medicine, that they give you a drug to cure headache does not mean it might not have side effects, but the pros and cons have been weighed and the advantage is more. That's why they give it to you to take it. So now, why containerized Java app? Why do we need to containerize Java app? Number one, simplifies deployment. Streamlines the entire development process, making it easy to manage application environments. You just bundle it into one container and you now ship it. So that's one advantage of containerizing our Java applications. Number two says enable microservices. I think one of the beautiful aspects of containerization is its use, its use case in microservices. Today, we discover one of the ways to scale our application and millions of users can use it, and it stands the workload and doesn't break down, is microservice. So when you bundle each of these applications as a container and you ship it out, they are independent. They can run individually, and you discover that the issue of, all this my app collapse is not there. So containerization also helps in the aspect of microservices. It facilitates horizontal scaling, works as seamlessly with orchestration tools. like Kubernetes for efficient horizontal scaling, adding more instances as needed, and so on and so forth. So another aspect of containerization is the aspect of horizontal scaling. We have vertical and horizontal scaling. I think it should be some of what we'll look at next. Yeah. So containerization helps to, horizontally scale your app. You tell your application by virtue of Kubernetes and how you set your configuration that, see, if the users increase to 1 million, double this application. If you increase to 2 million, double it. If you reduce to 100,000, reduce their instances. So that's what containerization also helps to do. It helps to make easier horizontal scaling. Containerization offers substantial advantages for Java developers, from simplifying operations to enabling modern architectural patterns, crucial for scaling. And you see, one of the things, like I say, as a developer, you must have in fact, if you have this at the back of your mind, no matter how many users keep increasing to use your app, you discover that solving that challenge will not be so complex, which is scaling. When you start building your application from the beginning, as a developer, have that mindset of this app must scale in case the users increase. Even if you were told to build it for 1 million people, you must put into consideration the fact that what if the users increase more than that? Okay, I built this app for 1 million, but I only have 500 users. Do I need to waste the resources allocated to this? It scales down. So scalability is one of the things as developers, if you have at the back of your mind, when you are building for all. When you are building for the world. When you are building globally. As far as that is in your mind, you discover that some of the issues many of our applications have today, it will not be there. So scaling strategies in containerized environments. I don't know. Let me move on. Like I said, time is limited, so some of these things I'll need to rush through it. Now, vertical scaling. Remember I talked about vertical and horizontal. What is vertical scaling? Vertical scaling involves adding more CPU, memory, or other resources to a single container or the underlying node it runs on. When you are increasing the capacity of your application, that's vertical scaling. Simple to implement, is straightforward, often just requires upgrading the cloud instance type. Hardware limited, eventually you will hit a ceiling for how much you can add to a single machine. It's talking about the limitation of vertical scaling now. When you have one app in your Docker and you're increasing the capacity, you are adding the CPU, or the CPU is too small, you are adding resources, you are adding this, or the database is full, let's expand it. Inside the application, you are vertically expanding it. When there's hardware limitation. But as you keep adding, you discover that there's a point whereby you can't add again. Some of us that buy some phones, they will tell you that the maximum external memory you add is 64 gig. If you go and put 124 or 256, it could crush that application. Because that phone was built to limit the memory it accepts externally to that goal. So that's one challenge of vertical scaling. Now, VPM tuning, critical. To efficiently utilize added resources, careful JVM, that's Java Virtual Machine now, tuning, heap size, garbage collector is essential. Now, as a Java developer, remember this scaling and whatever is in the scope of a Java developer. We must also put that in mind. That's why some of the things here, you discover that it has to do with Java, because when you talk about scaling and multi-threading, other OOP languages also have such concepts. But we are limiting us to Java because this has to do with the Java code. So Java JVM tuning as a developer is very important. I think this aspect are mostly handled by advanced, intermediate, and senior engineers. That's why when you are starting as a developer, all this JVM and memory, whatever, you might not actually come across it. But this is one of the very most important aspects as a developer, that your app will scale. You must saddle yourself with this knowledge. Most of us that have played guitar, you discover that as you are tuning, your guitar can lose its tune, and when you are playing it, it's off key. But if you're a good musician, you discover that when someone is playing without properly tuning it, you hear it. So as it tunes and tunes and tunes, it will come to a point whereby the sound is accurate, and when you are listening to it as an advanced music, whoever, you will know that, yeah, this is a correct musician. So our memory, the Java virtual machine, has resources, memories, and all that, that as a developer you can tune. For example, the memory you allocate to your application. Is it enough? Is it too big? Is it too small? And how are they being adjusted through tuning? That's what they call the JVM tuning. You know? While straightforward, vertical scaling has its limitations and needs to be complemented by other strategies for true elasticity. Remember that scaling has to do with when there are more users, you should be able to accommodate it. When there are smaller users, you should also be able to accommodate it. But vertical scaling has its limits, and that's why other means are being checked out, which brings in our horizontal scaling. Horizontal scaling is the preferred cloud-native approach instead of making individual servers more powerful, which is vertical. We add more instances of our application to distribute the load. This not only increases capacity, but also improves resilience. Kubernetes horizontal pod autoscaler automates this process based on what predefined matrices like CPU utilization, ensuring your application always has the resources it needs. Add more container instance to distribute load, require load balancing and stateless application design, Kubernetes horizontal pod autoscale. These are all ways of what horizontal scaling. We have talked about vertical, which has to do with your app itself. But talking about horizontal, you are going out. That's why they call it scale out. Vertical is scaling in within your app. Horizontal is scaling out. And what does that scaling out mean? Instead of increasing the power of your application, you are multiplying the instance. You have one soldier fighting the battle, you now multiply those soldiers. So when it comes to the native way of handling your application and making it scalable, horizontal scaling is one of the solutions. And one way Kubernetes helps does that is what? Horizontal pod autoscaling, HPA. When you configure your Kubernetes in such a way that as users are increasing, it automatically creates an instance of your application and expose it, and also coordinates how those instances are used. And whenever load reduces, what does it do? It reduces the instance. Like I said, beyond this class, is it for us to now start talking about all those things. So when we go through these slides, we will get more details and all that about that. Now, while you are talking about horizontal scaling, it's important you also talk about load balancing, because when you create instances of this application, requests will keep coming to it, and demands. Permit to use demand too, because request is either demand or whatever. Any request you send to your application hosted in any server. So you need to also talk about what the load balancing. Load balancing is crucial for effective horizontal scaling. It acts as traffic controller, intelligently routing incoming requests across your available application instances. This prevents any single instance from becoming a bottleneck, ensuring high availability and a smooth user experience. Think of it as a smart distribution hub for your application traffic. So when you're talking about load balancer, just like the name implies, 1 million requests are coming to an app that is expected to receive, let's say, 100,000 requests. So what load balancer does is, after your Kubernetes or wherever orchestration mechanism you are using creates instances for your app, load balancer now coordinates and properly regulate how those requests are distributed. It's quite funny that, let's assume you have 10 receptionists, and you see a long queue under one receptionist trying to attend to all those people in that queue. Is not also proper. And that's why that we're talking about this concept is not enough. Properly configuring and making sure it does what it should do the right way is also important. So load balancer make sure that I have 10 requests. Okay, who among my instances are free? Oh, this one is free. Oh yeah, 10 requests, go there, you go there. Depending on how you define it, because you can also define how those requests are handled, which is also a higher concept of what load balancing and all that. Now, JVM challenge in containers, virtual machine challenges. These are some of the challenges when you're talking about scaling your Java applications that you need to have in mind too. While containers offer great flexibility, they introduce new considerations for Java applications. The JVM's default memory management and garbage collector behaviors might not always align perfectly with container resources limits, potentially leading to what? Wasted resources or even OOM errors. Tuning the JVM is therefore critical for what? Efficient performance in containerized environment. You see, like I talked about multi-threading and its challenges, containerization also have its challenges, which come in the aspect of JVM management, basically. And that's why I talked about the fact that if you must properly make sure that your app, Java app, scales very well, you must saddle yourself with the skill of tuning the JVM, settings and whatever to align with what your app needs, either in the aspect of memory, either in the aspect of resources, whatever aspect your application needs to handle, your ability to properly tune it is important. Yeah, so these are some of the challenges. JVM memory management may not align with container. Yeah, default heap sizing can waste resources. Garbage collection, tuning critical for what? Performance. Key JVM setting for containers. To optimize your Java application in containers, understanding and configuring key JVM setting is vital. Flag lights, whatever, all these things. Please, because of time, we'll have to read through some of these things. When you talk about JVM, garbage collector, all those memory management, when your application is running, it creates, some unnecessary classes, objects that are not needed and need to be cleaned up. So your proper ability to tune these things and make sure it works well is important. Improving startup time and the rest. These are things that you can look up on yourself. These slides will be available for us, but like I said, because of our time, I can't go into them in detail. Now, best practices for developers. I think I'm approaching the conclusion now. These are some of the things, like I said, from the root when you are building application, you should put into consideration. For Java developers, adopting specific practices can dramatically improve the scalability and reliability of multi-threaded applications and containers. Designing stateless services simplifies, horizontal scaling. Using thread-safe data structure is essential for avoiding race conditions and robust error handling combined with comprehensive monitoring. Datadog provides crucial visibility. Final, automating builds and deployment ensures what? Consistency and efficiency. These are some of the things that you put into consideration as some of the root points you have while building your app. They were just outlisted. So I think I don't know if it's a good time to conclude now. Yeah, conclusion, your path to scalable Java app, scaling multi-threaded Java application in containerized environment is absolutely achievable with the right design, principles, and attention to detail. By combining intelligent JVM tuning, leveraging container orchestration like Kubernetes, and adhering to best coding practices, you can build applications that are not only performant but also incredibly resilient and adaptable. Start small, test tolerate, and iterate for performance and reliability. Embrace continuous learning in this evolving landscape. Like I said, this is just a piece, it is just a scrap in the main thing. Yeah, if this is something you really want to go into, it's deeper than this. So I don't know. Yeah, over to you. Yeah, thank you.
All right, Mr. David. First of all, I must say thank you very much for this wonderful exposition. As for me, I must say I've learned a lot, and I believe also for every other person here. So thank you very much for this wonderful presentation. And then we will now open the floor for questions and commendations. So we'll be taking 2 to 3 questions and then we'll be calling it a day. So I don't know if anyone here have a question for Mr. David Baba. You can go ahead and ask your questions. Okay. Mr. Bright is there with his hands up. Mr. Bright, you can go ahead. The floor is open.
Hi, thank you very much for such a great talk. I've actually learned a lot. Yeah, I have a couple of questions, but due to time, I'll just ask like one or two of them. And yeah, so you mentioned multi-threading and you also mentioned containerization, right? So I'm just thinking like what specific advantage does multi-threading, you know, offers to containerization? Like since we are talking about distributed system and stuff, right? So like what specific advantage do we get, in using multi-threading in a containerized environment that okay, we don't really get it in using it in other form of app, like other form of app packaging. For example, now I have an app that I didn't, containerize. I just, built the jar file and deploy, and I have another app that I containerized. So what, like, is there any specific advantage that multi-threading offers to this containerized app that I won't actually get in an app that I just, package the jar file and maybe push to the EC2 engine? So this is one question. The second one is, you talked about vertical, scalability, horizontal scalability. I believe those are, design, system design, patterns, and also, there are trade-offs, right? So, like, what will influence your decision in going for horizontal deployability over vertical? Because I want to believe that there is still some good in vertical, right? So, but what will actually influence your decision in choosing one over the other? Yeah, thank you. That's my question. Thanks.
Okay, let me quickly address the questions. Your first question is the advantage of multi-threading, right? In an application, why can't I just build my app and ship it there and it does the work? Why? What is the advantage of introducing multi-threading? Now, just like I said, some of these concepts are topics on their own. Time won't permit us to look into all those things. But you see, most object-oriented programming languages today have that concept of multi-threading. And why is it so? Because of throughput. Because of throughput. Yeah, there are some asynchronous processes that you just allow your system to just run, then bring the response at any time. And there are some of those processes that when you run it, you need the solution now. So you discover that multi-threading, let's assume that the work is to be done in 1 hour. Multi-threading gives you the ability to do that in like, you know, in under some minutes time. Some are so efficient that that 1 hour task can be done within 10 minutes. I'm just giving it a time illustration. But one thing you should understand is that any of your requests or API that is beyond, is it 2 seconds or so, is too fast. Is too, in fact, the timing is too much. You need to work on reducing it. But when we are talking about multi-threading, it highly optimizes your throughput. It reduces the time. And like I mentioned when I started, one of the things that keep users keep using your application is that whenever they are, let's assume I'm logging in and it's taking, 2-3 minutes, just to log in, it can discourage users from using your app. So if multi-threading is properly used, let's assume in that login, within seconds, as you click, it takes you into your app and you are done. So multi-threading, if you ask me, the most important aspect of multi-threading, advantage of multi-threading is that aspect of giving you a fast response time for your application. Now, quickly, I know that my answer might have not handled integrity too, but I know that it would have given you an idea of what multi-threading, uh, um, the advantage of multi-threading in applications. Yeah, yeah. And as little as that timing is, permit me to tell you that many companies, many applications have lost millions of users because of the response time. Yeah, response time. And it's when your application grows, those things become significant. Many of us, when we build our apps small, response time and all those things move smoothly. But when you deploy and users are hitting it, that's where you discover that the efficiency I feel is there in my local is never there. So we must always, especially as Java developers, put into consideration this aspect of multi-threading. Yeah, very important. Now, vertical and horizontal. If you remember when I was talking about vertical is, like you are internally optimizing your application. But like I said, it will have limits. It will definitely have limits. The resources you allocate to your application, the database or whatever you use, it will have limits. And at some points, expanding will come to a point whereby you can't do that anymore. So if you ask me, at what point do you use vertical versus horizontal? If you are going out and you are dealing with millions and millions of users, you can't escape horizontal scaling. It's very, very important. And it comes in many ways. Yeah. That your app serves a number of customers or users while it is little does not mean that when it expands, it can handle that. And vertical will not be able to handle that, especially when you are dealing with microservices. It will have limitation to the kind of workload it can handle. So depending on the point of your application, there are times whereby when you're just building a small app for people to just use and test run, you can just do your vertical whatever. As people demand is increasing, you know that the demand of users will not increase beyond this. You use little vertical, scaling and all that. But when it becomes robust and users are expanding and you are going globally, horizontal is to some extent a option you cannot escape. You definitely will have to make use of it. So I don't know if I've been able to touch your questions to an extent.
Okay, thank you very much. Thank you very much, both. Yeah.
Welcome. Thank you.
All right, Mr. David, thank you for doing justice to that question. I think Mr. Sam's hand is up, and Mr. Sam, you can have the floor.
Okay, thank you very much. I think Ade can go before me because of time. You can ask your question, Ade.
All right, Ade, go ahead.
Okay, the name is Israel, actually. Good evening, everyone.
All right, Israel, you're welcome.
Thanks to the moderator and at the same time the presenter. This has been a lovely, presentation so far. So, moderator, I would also like to inform you that we have Vamshi on board. So, I don't know, you might need to take time to look into that and, let's recognize them. My question is, let me say I have like a lot of questions, but because of our time, let me try and streamline this into just one, actually, but we still, reflect the other side. So, based on what so
Hello.
hello,
You mentioned something, I think I didn't.
I didn't get that. You said what?
Yeah, you mentioned something. I think I didn't get that clearly.
Yeah, I said we have Vamshi on board, so like we need to like recognize his presence.
All right.
You get it?
Okay.
Just try and check through the people available.
Okay.
Yeah.
Go ahead. Go ahead.
So my question goes by. So when designing a new application, understand. So how do you strike the right balance? Let's say between building for scalability from day one. You understand? Since we have to like start picturing how would scale from the first time you're writing your code. So and prioritizing between rapid delivery, knowing that definitely over engineering can slow you down, and yet neglecting scalability can lead to painful architecture later. So I would want to ask what principles or let's say decision making frameworks guide you in choosing the right points, along that spectrum of what we are discussing. Because we could take an example of we all know Upwork, right? You made an example of how it will take maybe 10 minutes for you to log in and all those sort of things. So I think that sort of experience I have experienced with Upwork, and Upwork is a well-known application out there. So I don't know if you get my question, sir.
Yeah. So, if I understand your question, how do we put into consideration all this aspect of scaling, multi-threading, containerization, right from the building block, right? From the design?
Yes, exactly. That's part of it.
Yeah.
How do you strike that right balance between building for scalability from day one, and
Yeah.
also prioritizing rapid delivery? Every organization, or every how am I going to put it now, VC wants to
Yeah.
jump into an MVP. People want like their product to be out like tomorrow. Understand? So how do you prioritize, or you strike the balance rather, so between that being scaling from day one and also prioritizing that rapid delivery? You understand? So understanding that you can over engineer things right
Yeah.
from time, and at the same time, you know you not over engineering also can be a painful thing later when you have to re-architect.
Yeah.
Understand?
Yeah.
So that's what I'm trying to get a feedback from you, so that we get that cleared up for me, sir.
All right. Okay. So you discover that, like I mentioned while I was presenting, there are always trade-offs for whatever decision we make as developers. So I think, if you will ask me, one of the trade-offs for efficient application that will stand the test of time is rushing. When you rush applications, definitely one way or the other, there will be omissions at some point. There are no two ways about it. And I think it's a thing for some of the startups that feel like, oh, we want to rush, we want to rush, we want to deliver. Definitely one way or the other, there will always be the trade-off of performance in that regard. And that's why when you check, some of the organizations which you can mention that are still standing today, and they are still, making progress and have been on ground for long. One thing they don't joke with is that they structure their development flow. What do I mean by that? They follow standards. And those standards are not compromisable. To some extent, because of those deliverable times, some of them employ the hands of more developers or even contract the work out just to make sure that they meet up with standard. But a number of the organizations that fall today and don't stand the test of time, if you check it, their processes are not actually well followed. In the software, those of us that have been in the software world, one of the things you will discover that is normal process for building application is the what do they call it now? Properly having engineering breakdown, having those tasks breakdown, having durations of time. What do they call it again? Sprints, and those sprints are strictly followed. Organizations that do that, you discover that they check the workload, they check the deliverable, and there's always what they call, expectancies. When they are testing your implementations, they are what they are checking against. So those things help in such a way that whatever you are building from the grassroots will be properly done. That's on a general note. Now, coming to you as a developer, you discover that when you are building to scale, there are fundamental principles as developers we need to use. Solid. There are fundamental principles we need to, the OOP concepts. Some of us violate those rules and we still expect our application to scale at some point. Take, for example, the logging in we're talking about now. Some people, when they are building a login system, for example, now, they can combine this login entity and whatever with other entities. Separation of concern is not there. You have a server that is handling user management and also handling transaction in one server. You discover that such thing can become an issue in the future. And microservices come in for our app to be able to be scalable. That's one of the things microservices come to solve. If you want to handle, let's say, user management, have a service for it, have a microservice for that, so that transactions will have a service, and this will have a service, that will have a service. So when you have those, solid principle, OOP concept being properly used, open to extension, right? Close to modification. You want to introduce a new, feature into your app. You have to now start scattering what you have built. That means that application was not properly, built on the concepts of OOP. So some of those things are the things that, if not properly handled, it can even start giving issues in the vertical scaling, not even the horizontal. Because there are some, scaling that you will want to do, and you are having issues with people logging in, but your services are combined now. If it were just, okay, we have authentication service now, that instance can properly be scaled and handled as a service, and other services will now, provide whatever they need to provide. So you discover that the design from the beginning, OOP concepts, separation of concern, and also, the software development processes that have been laid out, that need to be followed. If properly followed, you discover that we won't have issues with some of these applications and all that. Because when you put a developer under pressure to deliver a task that is supposed to deliver in a month, within a week, there is no magic about it. One way or the other, the problem will show probably in the future. So these are just few things, I believe, out of many things that, if properly handled or looked into, when it comes to scaling our application, when it comes to also, launching it out there, containerizing it, and people, user experience being smooth and okay, it could handle. Like I said, just some of it. It's just that time won't permit us. I would have given permission to some of us. Our ideas would have also helped. But these are just a few of what, if properly done from the beginning, your architectural diagram for your application, the services properly separated, following, OOP concept, the solid principle, dry principle, all those things. It will help your application to scale without any issue. Yeah. So thank you. I don't know if I've answered your question to an extent, because I know that is beyond what I've said. Yeah. Thank you.
Yes, thank you, at least to an extent, so that we don't waste time here. Please go ahead, moderator. You are muted.
All right, Mr. David Baba, thank you very much for your time here and for all the lessons you have poured out and the inspiring talks. Personally, I learned a lot from your talks and I really appreciate your time. Due to the time factor, we will not be taking more questions, but then we will still be meeting next week, Tuesday. Same time, we have a very hot topic coming up. I hope you guys are going to be there. Also, I will encourage everyone to follow up with what we are doing in the community. Right in the chat section, you can check the message there in the chat. We have our LinkedIn address there. We have our X address there. We have the WhatsApp address there. So do well. If you are not following in one of those communities, do well to join and follow what we are doing. And then do well to like our post and repost on the X platform. Then at this point, I will really have to thank everyone for calling it, making now time to be present at the JUG presentation today. I really appreciate your presence. Mr. Baba, I really thank you for this wonderful presentation and everyone present. And at this point, I will call it good evening and thank you for joining our section today. And do have a lovely evening. And depending on where you are, it could be afternoon, it could be morning, and thank you for joining. We really appreciate it.
And you could watch
Thank you very much. Thank you very much.
Yeah, thank you so much. All right,
Thank you very much.
see you guys next week, and do keep
Have a
active
nice.
on the platform. Yeah, thank you everyone. Mr. Bright, Um, I cite you here. So much thanks.